Hi, and welcome to this video in the series of how to use PSec GEARS for fixed income analysis. And today we're going to be talking about how to use and manipulate JSE yield curves in PSec GEARS. So first of all, these are the functions that are available. We're going to be going through some of them. Please feel free to pause the video and look at the functions, look at the help files in PSec GEARS and what they do. But I'm going to continue, and the first thing we're going to do again, we're going to look for the latest curve, which is going to be yesterday, and we're going to go to our trusty add workdays function and the pt.today and then -1. So this just gets the previous workday. We're going to select the curve that we want to look up something for, and at the moment the JSE really only has 3 curves that they publish, so that's going to be the swaps perfect fit, the bonds perfect fit, and the real perfect fit. All of these are 0 coupon curves, and there exists a function in PSec GEARS called the pf.0 curve to par, where you can convert them back to a par curve, and I'm just going to go with the bonds perfect fit curve. I want to look at what the 10-year point is, and I'm going to use an interpolation method. So this is a optional parameter, and the default in how the JSE constructs this curve is monotone preserving. So what this means, I can actually quickly show you. Let's actually interpolation, and I'm going to go to the overview. So you have these different interpolation methods: linear, spline, monotone preserving, achema. I'm not going to go into the technical details, but you have the x-axis and you have the y-axis. Essentially, you'd want to find out if you're on the x-axis at 3, so in between these. So these are the actual data points over here on your x-axis, and then on your corresponding y-axis, what these represent. So if you want to find out what the point is for 3, you don't have a data point there. So if you're using linear interpolation, you're just drawing a line, you're playing connect the dots in a straight line. And monotone preserving is kind of maintaining properties of how a yield curve should behave, so you're not experiencing things like this U-shaped of the curve. You're not going to have yield rate yields where it's lower for the 3-year than for the 1-year, unless your yield curve is slightly strange, and then higher again on the other side. But yeah. And then what we're going to do to actually look up the 10-year point on the JSE bonds perfect fit curve, we're going to come to pf.yield curve JSE, and I lied. We're going to use the yield curve lookup, and for the curve name we're going to use the bonds perfect fit. Curve date is yesterday, term is the 10-year, so your number in years, and the method is going to be monotone preserving for that. And the 10-year for yesterday is 12.45%. And again, we can also pull the entire yield curve to see if this is accurate. And let's not redo work, we're just going to use what we've calculated up here. And curve name this way. Also, you only have 1 point in your workbook where you have to change things. This really unlocks the true power of GEARS. So I can change to swaps PF and my entire workbook can change. So building your workbook in a smart way can really help a lot down the line. Let's change back to this. So if we look at yield curve JSE, so this does return the 0 curves of the JSE as they're constructed. We're going to use the curve date, we're going to use the output for, actually we're going to reference this, and it's just going to create a vector, so it's not important what we do. And here the source, this is an optional parameter, so you can either say you want a subset of the yield curve, which returns 150 points, or you can return the full yield curve as published by the JSE, and I just want the sub. This will just make it easier, and because we're using monotone preserving interpolation, we can actually get the exact JSE yield curve back from these points as well. And if we drag this across, I made a mistake. I should have followed my own advice and made these absolute. Of course, this actually, that stays the same. I can just drag them. And terms, of course, is a number, and this is a percentage. And what we can do here is we can actually graph this as well. This is perhaps a bad default chart. So scatter. And you have the yield curve for the 10-year. You can come up here. Yeah, it's about 12.4 as we've returned here. And we can also check this. What is the 10-year date? We won't have exactly the 10-year here, but with interpolation, we've gotten about 12.4%. And again, you can also return this using interpolation, but this essentially does what the function up here does automatically with the yield curve lookup. But you can use the interpolation function in a lot of different applications, so we're going to go through it here. So the lookup date, let's just do this, and this is going to be C lookup term. Actually, I'm going to do 10-year and lookup rate at date, so there's two ways to do this interpolation. So we can look at 10 years ahead, the date. So this interpolation function works with both dates and discrete numbers. And to do this, pt.interpolate. So we want x, we want the date. Let me actually do this for clarity. P206, and this is going to be in absolute numbers, and y is going to be the yield curves, so that's going to be D and D. And then what I want to do here is, let me check this, pt.addMonths. I'm going to do this, and I'm going to say 10 times 12, so that's 10 years in months. And the method, just using the JSC standard, is monitored on preserving. And this should give 12.4, and we can copy this over at term, and all we're changing here, we're changing 10. What have I done? So this would have to change to actually look at the year terms. So I'm just looking at the years and the dates and the rates, and these should be equal to each other. We can check this. Or they should actually be fairly close, because the dates may not exactly match up. So we can see what the difference is. And it's not going to, so it's less than 1/100%. Close enough. And that is working with yield curves in PSec GEARS in a nutshell. See you in the next video.